Tonight, we're going to talk about nothing. And I don't mean the absence of things or empty space or the void between galaxies. I mean the nothing inside everything. The nothing inside you, inside this planet, inside every star and every atom in the observable universe. Because here is something that should stop you cold. If you took every atom in your body and removed the empty space inside each one, compressed everything down to just the actual matter, the stuff that physicists would call real and solid and there, you would be smaller than a grain of sand. Not metaphorically, physically. Every human being who has ever lived, compressed to their actual matter, would fit inside a volume smaller than a sugar cube. The rest, everything else you think of as you, is nothing. Structured, organized, physics-obeying nothing, but nothing. And the deeper you look at that nothing, the stranger it gets. Let's start with something personal. Think about the last time you held something in your hand. A coffee cup, a phone, a set of keys. You felt it. The weight, the texture, the resistance as your fingers wrapped around it. That feeling is one of the most fundamental experiences of being alive. The world is here. I can feel it. It is real. Now here is what physics has to say about that. You never touched it. Not really. Not in the way you think. Every object you have ever picked up, every surface you have ever pressed your hand against, every handshake you have ever given, none of it involved actual contact between matter. Not once. The atoms in your hand and the atoms in the object never actually meet. They are kept apart by something else entirely. Here is what is actually happening. Every atom contains a cloud of electrons around its nucleus. Electrons carry a negative charge. When two objects come close to each other, the electron clouds of their surface atoms begin to overlap. Negative meets negative, like charges repel. Before any actual matter in your hand gets anywhere near any actual matter in the object, the electromagnetic fields of those electrons are already pushing back hard. What your brain interprets as solid physical contact, the sensation of touching something, is two clouds of electromagnetic force refusing to occupy the same space. The hardness of a table is not matter resisting matter. It is an invisible electromagnetic force field keeping empty space away from other empty space. By every step you have ever taken on solid ground, every time you have caught a ball or hugged someone or typed on a keyboard, every single physical sensation of your entire life has been electromagnetic fields interacting across gaps of empty space. The feeling of the physical world is not matter touching matter. It is fields touching fields with nothing in between. Sit with that for a moment, because the question it raises is obvious. If the things we touch are kept apart by electromagnetic force, if they never actually make contact, what are those things made of? What is inside the atoms creating those electron clouds? The answer is where it gets truly strange. In 1909, a physicist named Ernest Rutherford aimed a beam of charged particles at a sheet of gold foil so thin it was nearly transparent. His expectation was that the particles would sail through with minimal deflection. What he found instead was that while most particles did pass straight through, a small fraction bounced back at dramatic angles. Some came almost straight back at the source. Rutherford later said it was as if you fired artillery shells at tissue paper, and they bounced back and hit you. What this meant was extraordinary. The atom was not a solid sphere of evenly distributed matter. Almost all of its mass was concentrated in a tiny, incredibly dense core, the nucleus. And the rest of the atom, everything surrounding that nucleus out to the electron clouds, was essentially empty space. Here is the scale of that emptiness. If you took a single atom and scaled it up so that its nucleus was the size of a marble, 1 centimeter across, the nearest electron orbitals would be roughly 1 kilometer away. 1 kilometer of empty space between the nucleus and the first electron. The atom is a marble in the middle of an empty sphere, a kilometer in radius. Everything in between is nothing, not thin air, not sparse gas, nothing. And that is just the beginning. Because the nucleus itself, that marble, is not solid either. It is made of protons and neutrons, which are themselves made of smaller particles called quarks. And quarks, as far as we can currently measure, have no size at all. They are point particles, mathematical points with no physical extent. The closer you look for the edge of a quark, the more it retreats. The marble in our kilometer-wide atom is itself mostly empty space, held together by force rather than substance. The nothing goes all the way down, and here is one more layer that makes the emptiness personal. Your weight, the number on the scale, the gravitational presence of your body, is not coming from the particles inside you the way you might expect. The 3 quarks inside every proton account for only about 1% of the proton's mass. The remaining 99% comes from the energy of the forces and the motion inside those almost empty nuclei. You do not weigh what you weigh because of matter. You weigh what you weigh because of the energy of nothing doing something inside you. Now, here is something happening right now as you watch this. Approximately 400 trillion neutrinos are passing through your body every second. Neutrinos are particles with almost no mass that interact with ordinary matter, so rarely they treat solid objects as if they barely exist. A neutrino could travel through a light year of solid lead, not space, solid lead, and have a 50-50 chance of not interacting with a single atom. To a neutrino, the difference between your body and empty space is essentially nothing. The solid human being that feels so substantial and present is, from a neutrino's perspective, indistinguishable from vacuum. The 400 trillion of them are passing through you right now without knowing you exist. But here is the gear change. Because everything we have talked about so far is the easy version of nothing. The nothing of atomic distances, of empty space between particles. That kind of nothing at least makes intuitive sense. It is just a room, space with nothing filling it. The real nothing, the nothing that breaks physics, is something else entirely. It is the nothing of the quantum vacuum. And the quantum vacuum is one of the most mind-bending things in all of science. In classical physics, empty space is empty. Vacuum means nothing, zero energy, zero content, a region of space with nothing in it, doing nothing forever. Quantum mechanics says that is impossible. And the Heisenberg uncertainty principle states that you cannot have a region of space with perfectly precise, perfectly known energy. A true vacuum would have exactly zero energy. Perfectly known, perfectly certain. And that certainty violates the uncertainty principle, so nature forbids it. Perfect emptiness is not allowed. What happens instead is this. The quantum vacuum seethes. It churns with what physicists call virtual particles, pairs of particles and antiparticles that flicker into existence spontaneously, exist for an almost inconceivably brief moment, annihilate each other, and vanish. They appear from nothing. They return to nothing. They are happening everywhere, in every cubic centimeter of space, in the room you are sitting in right now, inside you, between the planets, between the galaxies. Without stopping for a single moment. The vacuum is not empty. It is the most active place in the universe. In 1948, Dutch physicist Hendrik Casimir made a precise prediction. Take two perfectly smooth metal plates, place them extremely close together in a vacuum, less than a millimeter apart. The virtual particles that flicker into existence in the gap between the plates are restricted by the geometry. Only certain wavelengths fit in the narrow space between them. Outside the plates, in the open vacuum, all wavelengths of virtual particles exist freely. That means there is more virtual particle activity outside the plates than between them. More vacuum pressure from outside than inside. The plates, Casimir predicted, would be pushed together by this imbalance, by nothing, by the pressure difference of empty space. When physicists built the experiment and measured the effect, it was there, exactly as predicted. Metal plates in a vacuum, pushed together by the activity of the empty space around them. The force was small but real and measurable, the nothing pushed. And if you think that is strange, what the quantum vacuum does at cosmic scales is where strange becomes genuinely unsettling. Quantum field theory, our best framework for understanding how the universe works, predicts a specific value for the energy density of the vacuum. The total energy of all those flickering virtual particles added up across all of space. When physicists run the calculation, the number they get is approximately 10 to the power of 120 times larger than the vacuum energy we actually observe. That is, a 1 followed by 120 zeros. It is the largest discrepancy between a theoretical prediction and an experimental observation in the history of physics, by an almost incomprehensible margin. The theory that gives us more precise predictions than anything else in science completely and catastrophically fails for this one. Physicists call this the vacuum catastrophe. Something is canceling almost all of the predicted vacuum energy down to the tiny value we actually measure. We have no idea what. It is not in any equation. It does not appear in any theory. Whatever is doing, it is the most precise cancellation in nature, by a factor that makes everything else in physics look rough. And here is the scale of what remains after that cancellation. If you converted the residual vacuum energy of the observable universe into mass, it would outweigh all the ordinary matter, every star, every planet, every galaxy, every atom of hydrogen in every gas cloud, by a factor of 10. The nothingness contains more mass equivalent than everything in it. The universe is not dominated by its contents, it is dominated by the properties of its emptiness. That residual vacuum energy is almost certainly what we call dark energy, the force driving the accelerating expansion of the universe. The leftover nothing, the rounding error of a cancellation we cannot explain, is tearing the cosmos apart. Now here is where it stops being unsettling and becomes something closer to alarming. The vacuum we live in might not be stable. Quantum field theory allows for the possibility that our current vacuum, the lowest energy state of space as we experience it, is not actually the lowest possible energy state. It might be what physicists call a false vacuum, a metastable configuration, like a ball resting in a shallow dip partway up a hill rather than in the true valley at the bottom. It is stable for now, but given enough time, or the right quantum fluctuation anywhere in the universe, it could tunnel through the energy barrier and collapse to the true lowest energy state. If this happened, a bubble of true vacuum would form and expand outward at the speed of light. There would be no warning. There could be no warning. Light is the fastest thing in the universe, and the bubble travels at light speed. It would not be a wall of fire or an explosion. It would be the fabric of reality itself shifting to a new configuration, one in which the fundamental constants of nature are different. The forces that hold atoms together might not work the same way. The electrons in every atom might not behave as they do now. The chemistry that makes matter complex and interesting might simply cease to function. Everything built over 14 billion years of cosmic evolution would not be destroyed. It would be unmade, converted into whatever form matter takes under a different set of physical laws. Instantly, everywhere the bubble reaches, with no warning of any kind. Is this likely? Probably not. Our vacuum has held for nearly 14 billion years. If it were easily destabilized, it would likely have collapsed long ago. Current calculations suggest that if vacuum decay is possible at all, it would not happen for at least 10 to the power of 100 years. There is no immediate danger, but we cannot rule it out. We do not fully understand why our vacuum has the stability it appears to have. The floor we are standing on, the very nature of the space we occupy, might be temporary in a way that has nothing to do with stars burning out or expansion thinning the cosmos. It might be a false floor, and if it ever gives way, there will be no time to know it happened. Here is the last layer, and it is the one that reframes everything we have talked about. Modern physics does not actually describe the universe as made of particles. The deepest framework we have, quantum field theory, describes reality as made of fields, not particles. Fields, an electron field permeating all of space, a quark field, a photon field, a Higgs field. These fields exist everywhere simultaneously, filling every point in the universe at all times. What we call a particle, an electron, a photon, a quark, is not a tiny object sitting in space. It is an excitation of the underlying field. A ripple, a temporary localized disturbance in something that is already everywhere. Think of the surface of a calm pond. The water is the field. It exists everywhere. Drop a stone and ripples spread outward. Those ripples are the particles. They are not separate things floating on the water. They are the water, disturbed. Every atom in your body, every photon of light that has ever entered your eyes, all of it is ripples in underlying fields that fill all of space. The matter is not the fundamental thing. The field is the fundamental thing. And between the ripples, the field is still there. The electrons in your atoms, we said they do not have definite positions until something interacts with them. They exist as probability distributions smeared across space, collapsing to a definite location only through interaction. The solidity you feel is real. The electromagnetic repulsion is real. But the underlying substrate of that solidity is not a collection of precisely located particles in well-defined positions. Nay, it is a set of ripples in quantum fields, resolving into definite outcomes through constant interaction, producing the reliable and apparently solid world you experience. Here is what I keep coming back to when I think about all of this. We started with the most basic question: what are things made of? It seemed like a question with a solid answer waiting at the end. Particles, atoms, building blocks, a floor to stand on. But the floor keeps giving way. The atom is empty. The nucleus is empty. The quarks have no size. 400 trillion particles pass through you every second without noticing you are there. The vacuum seethes with energy we cannot explain. That energy outweighs all the matter in the universe. Its residue is driving the cosmos apart. And yet, out of all of this, emerges a universe of extraordinary complexity. Stars and galaxies, chemistry and biology, consciousness, the ability to sit in a universe made almost entirely of nothing and ask what it is made of. The nothing is not a flaw in reality. It is the architecture of it. And the vacuum is not the absence of the universe. It is the universe, with matter as its rare and temporary exception. And for this brief moment in cosmic time, We are that exception. Patterns of structured nothing, complex enough to contemplate the nothing we are made of. That is not a small thing. That might be the most extraordinary thing in the observable universe. Good night,